Temporal means something related to time, something that moves over time, and you want to detect its motion correctly without creating artifacts in a way that is, for example, what exactly is the importance of temporal resolution in certain specific cases? Why is it specifically important in these cases? Why? Because at this time, I rely on what? I rely on the fact that there is motion, and you are achieving this motion. For example, if you are imaging in echo cases, the same idea applies. You are in a situation with mechanical movement and motion, and you want to capture this motion, right? So when you take the image and achieve the line in this way, you tell it that you want to see the change in motion or the change in movement over a certain time or unit of time. This is the curve. Now, if you don't have it, if your imaging modality cannot perform detection, or if its frame rate is slow, or if there is an issue with the signal reception, will you be able to achieve higher detectability or high resolution in this matter? No. So, temporal resolution is very important in situations that involve motion, such as echo. Of course, there are different types of modes available in ultrasound. I want to ask you a bit. Are there cases in ophthalmology or cases that have, for example, retinal detachment? Is ultrasound useful in these cases? Yes? Because what they call A mode means that most of you work with B mode, right? Or in M mode, for example, which is the first A mode they used. Is there anyone working with it? Every time you increase the number of bits, it means you are increasing the pixel depth. The same applies to dynamic range, which means you are improving the contrast resolution. The dynamic range means you are enhancing the contrast resolution. If you improve it, keep in mind that if you increase the pixels too much, it won't be connected. For example, if you increase the pixels to show a clearer image or something like that, no. The question is, Dr. Hani, what is 72? So, 72 indicates what value? For example, you should know your bit depth, or how many gray values are present, like 72. You mean the display that exists. If it increases too much, like we do, your image will wash out. Even if you increase or adjust the windowing, it shouldn't increase with you. Oh, that's strange. I mean, if you have a picture of it, like perhaps possibly, could you send it to me? If you have an image of it, can I see it? Because strangely, this is a whole image. Does it have details or not? Maximization can work with existing signals, such as the stronger signals, which can greatly enhance brightness. However, it must perform something called normalization, as if it balances everything, no matter how much the bits are increased. It is doing normalization. What does it mean to work like this? It's not just about increasing the levels, it also enhances the high levels, improving them through normalization in the end. Ideally, the quality should be homogeneous. But if it increases significantly, that's a bit strange. Is this on the machine, Dr. Honey, or on any machine you've worked on? Well, if you have an image, I haven't really worked on ultrasound, but if you have an image, like a movement, for example, send it to me and I'll take a look to see what might have happened. So, we have talked today about focusing and the beam. We discussed the types of our transducers and we talked about the parts: resolution, lateral resolution, contrast resolution, and temporal resolution. We are supposed to, we are supposed to cover the part that is left with us, which is A mode, B mode, and M mode, that we need to discuss in detail and thoroughly in our session today. This is not much, and we will explore the intricacies of the various modes in ultrasound technology, including harmonic imaging as well, which is quite fascinating. I will leave that for next time, along with the different modes. There is something we will talk about next time, which is dynamic range, compression, and reject. This refers to the imaging process itself, meaning what happens after the signal is taken. After the signal returns to the transducer, it starts to process it by applying compression and amplification, and the role of time gain compensation in compensating for time gain. Dr. Islam might have asked me about this topic when we were talking together, and we mentioned that the signals coming from higher depths are supposed to be attenuated. We discussed how it calculates the amount of attenuation that occurred by disabling it and starts to compensate for this using, of course, TGC, or time gain compensation, which is present on most of the machines. It adjusts the gain or the amplitude to equalize the signals coming from higher depths with those from the surface, so the image starts to appear better or clearer. The image will remain homogeneous for me, meaning along the whole depth of my image. They will show the images that are clear among us, highlighting the difference between the image without time gain compensation and the image with time gain compensation. This is called amplification, and we will talk about it, meaning this is one of the things that is post-processing for me. There is also, and we will talk about it. This is one of the things that is post for me also. There is something called reject. What is reject? It is the process of removing light or filtering out the stronger echoes that come to it. Of course, it has echo, it has a graph, it has echoes of weak signals that create a fuzzy appearance or cause noise like this, so it can reject these weak signals and improve the signal or enhance the appearance by removing the existing noise. There is something called compression, and we will also talk about it next time, and its role in image quality After that, after the modes and compression, we should have the part about ultrasound safety and ultrasound artifacts. Okay, God willing, we will try to have the lecture next week, specifically on Thursday, Friday, and Saturday. On Friday and Saturday, we will completely wrap up. God willing, there will be a lecture, and I hope, God willing, that the remaining part about the modes is small, not large. I will just ask for your understanding as I am quite exhausted. So I will conclude here. The lecture is a bit short, but please forgive me, and we will continue, God willing, next time. Subscribe channel.